Hello people, welcome to the channel, and today we're going to be looking at using hydrocarbon fuels. Okay, we're going to be looking at the two types of combustion, complete and incomplete combustion. We're going to look at the products, we're going to look at how to balance the combustion equation, and we're also going to do some calculations about the amount of certain reactants or product being formed when a combustion reaction happens. Okay, so let's jump into it.
It was a nightmare.
Activate.
Right, so using hydrocarbon fuels. To start, we're going to have these 5 questions, starter questions to recap information from previous lessons. We're going to do a tick and fix, which basically means that you can pause on the video, and once you've done that, answer your questions, and then you can press play and you can correct your answer. If you got them right, you give it a tick. If you got them wrong, you got to fix it and put the actual answer in there. Okay, so you can press pause now. Okay, right, so now that you completed those questions, let's have a look at the answers. So in this specific diagram here, what we have is a quick example of how fractional distillation works. Okay, so we have some crude oil over here, and it's been soaked onto a mineral wool. What you do is that you apply some heat, and because crude oil is a mixture of all these different hydrocarbon chains, what will happen is that the small hydrocarbon chains will actually evaporate first, and as they cool down, they turn back into a liquid and they condense, and then you can collect them. So in this diagram, they're collecting the first section, the second, and right now they're collecting the third section. Okay, so we put it into cold water, so the whole test tube is going to be nice and cold. So when the vapor goes out of it, what will happen is that it will turn back into a liquid. So if they ask you to design an experiment on how you can actually extract the different fractions from crude oil, this is the kind of thing that you're looking at. Okay, so a hydrocarbon chain in crude oil have large amounts of energy chemically stored, and in order for them to release that energy, the fuels need to be burnt. Okay, now combustion is when a fuel is burned in the presence of oxygen, and it produces carbon dioxide and water. Okay, so if you see this for instance is the fuel, it will burn in the presence of oxygen, and as a result you're gonna get carbon dioxide and you're gonna have water as well. Okay, now during the complete combustion, all the fuel is reacted with oxygen and all the energy is released, and this is very important. This is complete combustion. Okay, all the carbon is bonded with oxygen, therefore there is no soot, and no soot is produced, therefore there is no black smoke being produced. Okay, now during complete combustion you will have blue flames, and they give a lot more energy than yellow flames do. So task number 1, we're going to start with this. As always, you can press pause when you start doing your work, and then you can press play so you can correct your answers. Okay, so first of all, it says write down the chemical equation for the combustion of methane gas. So you just got to write down the symbols. Okay, and then the next one says describe why burners in a stove are designed to burn methane gas with blue flames, giving out blue flames, not the yellow ones. Okay, and if you want to take it to the next level, you can balance the chemical equation for the combustion of methane gas. So as always, you can press pause on the video, and then you can check your answer. So press pause now. Right, so now that you're back, you finished doing your answers, we can mark them up. Okay, right, so here we go. Here we got the answers. Now answer number 1, it says we have the chemical formula, which is CH4 plus H2O gives you carbon dioxide and water. And then the second part was because they need to be able to release as much energy as possible to save gas when cooking, and also not to produce soot that could cover the kitchen. And then here we go, your balanced chemical formula. Okay, so tick those. If you got them right, congratulations. If you got them wrong, you need to write down the correct answer. Okay, so by now you should be able to describe what complete combustion is and its products. Okay, so let's see. Incomplete combustion is when a fuel is burned without enough oxygen. It produces carbon dioxide, carbon monoxide, carbon particulates or soot, and also water as products. Okay, so during incomplete combustion, less energy is released and the fuel burns with a yellow flame. In school, you will normally be told that this is the safety flame. Now, the different hydrocarbon chains will need different amounts of heat to completely combust. The longer the chain, the more energy is needed for and the more oxygen is also needed as well. Because the hydrocarbon chains in diesel are longer than in petrol, it requires more energy to ignite, and it also produces more soot than petrol does. Okay? Task number 2. Answer the following questions. Write down the main differences between complete and incomplete combustion. Suggest why racing cars have extra vents called superchargers on their bonnets. Okay, so as always, you can press pause on the video and then you can check your answers. You check and you fix. Okay, so press pause now. Right, so here are the answers for you. Right, so let's move on. By now, you should be able to describe what complete combustion and its products are. You should be able to describe what incomplete combustion and its products are as well, okay? So now we have to look at how to calculate the amount of certain products in a chemical reaction, and we normally use chemical equation, okay? And this is a part that is a bit difficult for you guys if you find difficulty with this, obviously. So I'd like you guys to pay attention, and then oh, it's not like you can't rewind the video, but in any case, let's just go for it. Okay, now if you have any fuel, you burn it with oxygen and then you get carbon dioxide and water as a result. Okay, if there is no oxygen, you can't burn anything. Okay, now even when you see movies in space, though, you see this massive explosion and the ship is going down on flames in space. It's a bit fake. It's a bit fake because obviously, as there is no oxygen, or relatively no oxygen in space, there shouldn't be any fires in space. Right, so it says normally a container of liquefied butane C4H10 contains 5 kilograms, which is reacted with oxygen during combustion. Okay, so when you go camping, you have a canister with fuel that's a butane gas. It can contain a certain amount of kilograms worth, and then you gotta burn it, you react it with water, with oxygen, okay, to produce water and carbon dioxide. Now, before we can do any calculation, we need a balanced chemical equation. Okay, so what we got here is a balanced chemical equation, but how do we get there? Okay, the first thing you got to do, if you look at my other video about how to balance chemical equations, I might put a description there somewhere. First, you got to count how many atoms of each element you have in each side, and we always going to start with hydrogen. At least that's the method I prefer. Okay, so we start with hydrogens. In this side over here, we got 10. In the other side, we got 2. Oxygens, we have 2. Oxygens, we have 2 there, and we have 1 over here as well. Okay, so it's important for you to keep them separate, otherwise it is a mission to try and figure it out. Okay, so carbon over here, number 4, and then we have carbon over here, number 1. Right, so we always start with hydrogen, make the small number equal to the big one. So that number there, we multiply it times 2 to make it 20. Obviously that is not the same, but we're gonna find out why it's not the same, because afterwards we gotta do another calculation as well. So let's see. So far so good. Now we have that there. We multiply that one times 2, and that gives us 20 as well. Now because that 2 is multiplying that carbon over there, you're also gonna have to multiply that carbon eventually. So over here we have 1 oxygen from there. That 10 that we put for the hydrogen is also gonna multiply that oxygen, so that's why we got 10 over here. Okay, and this one we multiply it times 8, so we can get 16, and when we add both of them you get 26, and this side we times that by 13, so 13 times 2 equals 26, and this is the last bit over here. Okay, now you had 8 over here, and that 8 is going to multiply the carbon, so that's why you end up with 8 carbons, and over here that 2 that we put there before is going to multiply the 4, and you're going to end up with 8 carbons as well. So now the equation is balanced. You got 20 hydrogens, 26 oxygens, 26 oxygens when you add 16 and 10, and then you will have 8 carbons in each side of the equation. Okay, so we're done with calculations now. We're going to go to the next part. It says the equation above tells us that with 2 moles of butane gas, that's your 2 moles of butane gas, 2 moles of butane gas, plenty of oxygen, you can produce 8 moles of carbon dioxide. So that's your 8 moles of carbon dioxide and 10 moles of water, as you can see over here in the balanced chemical equation. Okay, so how much is 1 mole of butane in grams? So normally what you would do is that you have the molecule of butane, you calculate the relative atomic mass, and that will be in relative mass units, and this is what we got. So we got 48. You got each carbon is 2 atomic mass units, each hydrogen is 1, so you multiply that times 4. okay, because you got 4 carbons in there, so it'll be 12 times 4, and that will give you 48. And then you have hydrogen, which you got 10, so 1 times 10 equals 10 atomic mass units. You add both together and you get 58 grams, okay? So in 1 mole of butane gas, you have 58 grams, okay? Or in 58 grams of butane gas, you have 1 mole of the butane gas itself, okay? Now, how much is 1 mole of carbon dioxide in grams? So you do the same thing. Carbon dioxide has got 1 carbon and 2 oxygen, so 1 carbon is 12, oxygen is 16, so you go to 12 times 1 equals 12 atomic mass units. Then you have oxygen, 16 times 2, because you got 2 oxygens over here in carbon dioxide, so that's going to be 32 atomic mass units. You add those two together and you get 44 grams. Now, how many grams of carbon dioxide can be produced by burning 5,000 grams of butane? Or you can also say 5 kilograms, because you have 1,000 grams in 1 kilogram. Now you're wondering where these numbers are coming from, okay? So 58 grams is that, because 1 mole of butane gas is 58 grams. So if you divide the 5,000 grams by 58, is the total of moles that you would have, okay? Now it also tells us that over here, 2 moles of the butane gas is 8 moles of carbon dioxide. And it's the same thing as saying that 1 mole of butane gas, it would be 4 moles of carbon dioxide. So whatever you have there, you times it by 4, and then you times that again by 44 grams, because that is the relative formula mass of the carbon dioxide, and that's going to give you your answer, okay? Right, I know it's a bit confusing, and if you need to recap through it, you can just rewind the video, and that's the advantage of having this here. Otherwise, you can drop me any messages in the comments, and I'll try to get back to you, okay? Now, task number 3. A cylinder of propane contains 16 kilograms of liquefied gas. Using the balanced chemical equation, calculate the minimum mass of oxygen needed for the combustion of the gas in the cylinder. Okay, now it all sounds very wordy, but it's more or less the same as we just did in the previous exercise. Okay, so as always, you can press pause and do your working out, and then press play again so you can mark your answer. So you tick and fix. All right, so you tick it if you got it right, and you fix it if you got it wrong. Okay, you write the correct answer. So you can press pause on the video now. Right, so now that we got the balance equation over there, let's move on to the next part. Over here it says how many moles of butane gas do you have in grams. So you do the whole calculation again, you get 44 grams. So 44 grams will be 1 mole, and you have 16,000 grams. So you divide that by 44 to find out how many moles of the gas molecule you actually have. Then you times that by 5. Okay, the reason for that is because over here in the chemical equation is telling us that with 1 mole of the gas, you're going to need 5 moles of oxygen to do it. Okay, so whatever number you get from this division, you times it by 5, then you times it by 32, because each oxygen is 16, so altogether the oxygen molecule will be 32. All right, so you times that by 32 and you get that. You can ignore this section here because that is meant to say O2, O2, not C. I don't know why I didn't change that. I just made that mistake there. Okay, but the whole point is that you do exactly the same process, and then you have your answer over here. Okay, so by now you should be able to describe the difference between complete and incomplete combustion and what the products are. You should be able to write down a balanced equation for the combustion of a hydrocarbon. Okay, now if you have any questions, you got any queries, you can drop me a message in the comments below, and I can try to get back to you. So like and subscribe, and remember, knowledge is power.